All right, guys, we're working on Unit 7, Lesson 18, dividing whole numbers by decimal numbers. And we're just going to start with talking about that shift pattern. So this should seem pretty familiar and hopefully go very fast as far as the shift pattern goes. SAB page 315 to 320. Okay, so we're just talking about how when you divide by a decimal, things shift. So Jordan earns $243 a week. The money's shown. Okay, if we divide that by 1, we would get $243. So that's how many actual bills there are. But if you were to break that up into dimes, it's asking how many dimes there would be. Well, because a dime is worth 10 cents or 1/10, it would all shift over and they would have 2,430 dimes. Oops, I don't want to have that dollar sign in there. Sorry, guys. Dimes. Okay? Because it's not dollars, it's dimes. Okay? So what happens to each dollar? It becomes 10 dimes, right? Because there are 10 dimes in a dollar. Okay? So what happens to the number shown in Jordan's earnings? Well, it becomes 10 times as great. I'm going to go back up here and say 10 dimes per $1. Okay? And then again, because each dollar equals 10 dimes. Okay, so when you divide by a tenth, the digits shift left because dividing by a tenth is the same as multiplying by 10. Okay, so think about that when you're dividing by 10. I'm missing one question. It says how many places does each digit shift? You're going to say 1. 1 place shift. Okay. All right, so how many pennies does he earn then? Well, he would earn 24,300. Each dollar becomes 100 pennies. So $1 equals 100 pennies. So the earnings become 100 times as great. When you divide by 1/10, each digit shifts left because dividing by a tenth, or a hundredth, sorry, is the same as multiplying by 100. Okay, we move 2 places because each digit is 100 times greater. Okay, so how many hundredths of a cent or thousandths of a cent does he have? Sorry, thousandths. Well, 243,000, right? Each dollar becomes 1,000th. Tenths of a cent. It's 1,000 times greater. Okay, and you shift left again, and we shift 3 places. Okay, we shift left because it's like divided. When you divide by 1,000th, it's like multiplying by 1,000. Okay, so hopefully that's kind of starting to make sense. Like I said, when we do these, shift patterns, it all kind of repeats and follows. So how many tenths are in a whole? Well, 10 tenths in one whole, right? So when we take one whole and we divide it by a tenth, it's 10. The answer is the same as taking 1 times 10. Okay. So if Mr. Marino made 2 liters of spaghetti sauce, he'll also pour into jars that each hold a tenth of a liter. How many jars will he need? Well, how many tenths are in a whole? 10. So how many are in 2 wholes? 20. Okay, so 2 divided by a tenth is 20. And the answer is the same as 2 times 10. Okay. The Marinos made a kiloliter of fruit punch for a large party. They're going to pour it into punch bowls that each hold 100 kiloliters. How many bowls will they need? Well, how many hundredths are there, excuse me, in one? Well, there are 100 hundredths in a whole. So 1 whole divided by 100th is 100. So that's the same as 1 times 100. Okay. Why do we get a larger number when we divide by a decimal number? It's because when you divide by a number that's less than 1, you find out how many of those pieces or parts are within that whole. Make sure you have some kind of answer here. We'll talk about this in class. So I've kind of explained it. Re-listen to it if you need to. We'll discuss in class with our table groups. Okay, so we get a larger number when we divide because of the way that you're dividing those whole numbers into parts. Okay, welcome Puzzle Penguin. One of my friends says that dividing a number by 1/10 is the same as multiplying by 10. He also says that dividing by 100th is multiplying by 100. He also thinks that's true for 1,000th, 1,000,000th, and so on. Is he right? I don't see how this can be true. Usually multiplication gives us a larger number and division gives us a smaller number, so this would be very strange. Can you explain? So we need to answer Puzzled Penguin. When you multiply by a decimal, it does give a smaller number. But when you divide by a decimal, it gives a larger number. Okay, so that's just the way it works. Think about when you divide a whole number up into bits and pieces, you're going to end up with a larger number. So when we look at this problem here and we're thinking about is it easier to divide when the divisor's a whole number? You can change the divisor by a whole number using this strategy below. So 6 divided by 2/10, right? The first step is we know that that's like this. We can make it as a fraction. But we can also, when we work with fractions, remember, we can apply our rule. Whatever you do to the denominator, you have to do to the numerator, and find an equivalent fraction, which would be like this. Okay, multiplying 6 times 10 and 2/10 by 10, so we get 60 divided by 2. So then we're actually taking 2 into 60. Okay, well 2 into 60 is 30. Okay, so you know, we've multiplied the numerator and the denominator by the same number, so the quotient will be the same. Our answer will be the same, because as long as we work in equivalent fractions, we're going to end up with the same numbers. Okay, let's take a look at the next page. You can multiply each number by 10 doing long division format, so this is just shifting that decimal over. So you can absolutely shift the decimal over. I've done this with you guys multiple times. I usually do it this way, okay, where you shift that over. Moving the decimal in both places, the same number, is making an equivalent fraction. So when we move the decimal, the same number of places is the same as making an equivalent fraction. Okay, so let's take a look at these problems down here. I want you to try some out. Right, I already did this one. What number can we multiply 2/10 to get that whole number, or 2/1000? We would multiply it by 100. This is real similar to that last problem we did. So it would be 300, okay, when we do long division. And this one would be 3,000, okay, because you're just multiplying, you're shifting it over. So you can think about moving the decimal 1, 2, 3 places, which would mean you need to move it 1, 2, 3 places. Okay, I want you guys to try out 25 through 28, and we'll share those out in class along with the other answers from Puzzled Penguin and our discussion question.